We are talking about quadrilaterals, and we want to test to see if quadrilaterals are parallelograms. And we want to prove that a set of points forms a parallelogram in the coordinate plane. So we have example 1. Prove that the quadrilateral with coordinates O is -2, 3, K is 4, 3, R is 2, -2, and A is -4, -2 is a parallelogram using the midpoint formula. So in this case, I'm going to sketch the quadrilateral. We haven't proved that it's a parallelogram yet. And once we have it sketched, it's easier to see that we're going to have to check for 2 diagonal midpoints. So we want to check between K and A and O and R. So we want to check the points between K and A. So midpoint formula, the things that don't change, plus divide 2, plus divide 2. Then we want to check the x's. So 4 goes in for K, -4 goes in for A. Check the y's. 3 goes in for A, -2 goes in, 3 goes in for K, -2 goes in for A. Do our math, we find the coordinate of 0, 1/2. So 0, 1/2 is right there. Then we want to check OR. So the coordinates for O, again, the things that don't never change, plus divide 2, plus divide 2, those never change. And then the coordinates for O, the x value is -2, the y value is 3. Coordinates for R, x value is 2, y value is -2. And again, we get the coordinate of 0, 1/2. So that's the same coordinate. So because it's the same coordinate, that is a parallelogram because diagonals bisect. Both the midpoint of AK and the midpoint of OR are in the same location. So that is a parallelogram. Number 2. Prove that the quadrilateral with the coordinates of M is 1, 1, I is 2, 4, N is 5, 6, and T is 4, 3 is a parallelogram using the slope formula. Now we have to do this one 4 times. We have to check each one of the slopes. So the first one we're going to check is IN. In IN, again, the things that don't change, divide with a minus sign in the numerator, minus sign in the denominator, and then we just stack the coordinates. So I coordinate is 4, 2, 4 over 2. N, the coordinate is 5, 6, so 6 over 5. And we end up with a slope of 2/3. And that makes sense. Up 2 over 3, that's true. The one that's going to check with that we want to see is MT. If MT is not parallel with IN, we're done. So we check it. The coordinates for M are 1, 1, so 1 over 1. The coordinates for T are 4, 3. Y value goes in the top, so 3 in the top, 4 in the denominator. And we get 2/3, so that's true. We know that IN and MT are parallel, so then we have to go on and check. Check MI. Coordinates for M, 1 over 1. Coordinates for I, 4 in the numerator, 2 in the denominator, and we get 3. So we just got to check TN. Coordinates for T are 3 for the Y, 4 for the X. Coordinates for N, 6 for the Y, 5 for the X, and we get 3. So because TN and MI both have a slope of 3, and IN and MT both have a slope of 2/3, this is a parallelogram because opposite sides are parallel. Number 3. Prove that the quadrilateral with coordinates K is 3, 2, A is 6, 2, L is O, negative 2, and E is negative 3, negative 2, is a parallelogram using the distance formula. And in this case, we have to check 4 distances. So we have to check Ka, and we use the distance formula. Again, the things that don't change, the radical will always be there. The parentheses, 2 sets of parentheses will always be there. The minus sign in the middle will always be there. The plus sign will always be there, and both sets of parentheses are squared. So K, X value is 3, Y value is 2. A is A value, or X value is 6, Y value is 2. We do our math, and we end up with 3. So we just did Ka. So now we're going to check EL. If EL is 3, then we're good to go. EL. E, the X value is negative 3, the Y value is negative 2. L, the X value is 0, the Y value is negative 2. Do the math and we get 3. So we're all set there. So now we got to check LA, distance from L to A. Again, the coordinate for L is 0, negative 2. And the coordinate for A is 6, 2. So we do our math, and we end up with the square root of 52. And we're just going to leave this here. We don't have to reduce it because we just want to check and make sure that ER is also the square root of 52. Coordinate of E is negative 3, negative 2. Coordinate of R, oh, that's K. Coordinate of K, got to write neater. Coordinate of K is also 3, 2. And so we do our math, and we end up with the square root of 52. So this is a parallelogram because opposite sides are congruent. And then the last one, we want to prove that the quadrilateral with vertices of B is negative 3, 1, E is 2, 6, A is 9, 5, and N is 4, 0 is a parallelogram using the slope and distance formula. So we have to check 2 distances and 2 slopes. So I just picked BE, but you could pick either one. So BE, check the distance, and we get a distance of the square root of 50. So that's distance there. We also need to get the slope. Using the slope formula, we find out that the slope of BE is 1. So up 1 over 1, up 1 over 1. So that's correct. Now we want to check if NA is also congruent and parallel to BE. So we'd use the distance formula, and we find out that the distance from NA is also the square root of 50. So they both have a congruent distance. And then we check the slope of NA, and the slope of N ends up being 1. So the slope of BE is 1, and the slope of NA is 1. So because BE is congruent and parallel to NA, this is a parallelogram because opposite sides are congruent and parallel.